Okay, here we go. Number four. Sorry about getting these late to 2010. Number four. An automobile company wants to learn about customer satisfaction on five specific models. Large sales volumes have been recorded in three of the models, but the other two were recently introduced. Sales have been smaller for these guys. A company can obtain a list of all individuals who have purchased new cars over the last 6 months, and they want to sample 2,000 of these owners. So we want to sample 2,000. For a simple random sample of 2,000 new car owners, what's the expected number of owners of Model E and the standard deviation of Model E? Well, when you first look at this, it's like, I don't know. How do I handle this? Um, well, if you look at this way, I'm picking 2,000 owners of cars who bought, or owners of new cars. They either picked E or they didn't pick E. That's a binomial experiment with n equal 2,000. So if n equals 2,000, what's the probability that they pick E? Well, that's going to be 23 out of 297,354. 23, I've got my calculator here. 297,354 is, oops, 0.0078, or 0.78%. That's a probability of success, or that someone would pick car number E based on this number of new car owner purchasers. So we can use that, and we can assume that it's binomial because it's such a large number. So we're going to go ahead and say this is a binomial distribution. We've got n and we've got p. As long as we say those things, I can go ahead and use the binomial distribution formulas. Now for the expected value, that's the mean, and both of these formulas are in on your note sheet. And for the standard deviation, sigma, this is NP, which is 2,000 people, and then the probability of success is 0.0078, and I would actually leave that number in your calculator, not rounded, times 2,000, although they're pretty forgiving when it comes to rounding, is equal to 15.6, and standard deviation is square root of NPQ, 2,000 times 0.0078 times 1 minus 0.0078, 0.9922, and you get 2,000. This one you kind of have to just round those, but I'm going to go ahead and do it to 4 decimal places. So we get 3.93. Okay, so there's A. So I would expect 15.6 people to choose car E with a standard deviation of 3.93. B. When selecting a simple random sample, how likely is it that fewer than 12 owners would be included in the sample? Well, since this is binomial, n is 2,000, p is 0.0078, isn't this the probability that I choose less than, fewer than 12, or equal to 11 owners of car E? So this is really a cumulative distribution. This is equal to the probability that I get 0 plus the probability that I get, x equal 1 plus the probability that I get x equal 2 all the probability that I get x equal 11, right? And the way you do that is binomial CDF. I'm going to write it down here, but you do not have to write it on your paper. Binomial CDF, and it's 11.0, I'm sorry, not 11, it's N 2000.0078, 11 successes. And if you do that, you should get, I'm actually going to do it here, 2000.0078, 11. 14.7%. So there's a 14.7% chance of that happening. C. Companies concerned that a simple random sample would include fewer than 12 owners of Model D or fewer than 12 owners of Model E briefly describe a sampling method for randomly selecting 2,000 owners that will ensure at least 12 owners will be selected for each of the 5 car models. I would do a stratified, a proportional, stratified random sample. I would select sorry, I had to pause it there for a second. I would select 1 1 12 3 3 8 out of 2 9 7 3 5 4, which is divided by 2 9 7 3 5 4, 37.8% of my sample, 2,000. So times 2,000, 755.5. So I'd select 756 from car model A buyers. Etc. But in particular, they want to ensure that we select 12 for each of the 5 car models. So in particular, I would just mention because I want to make sure I get 12 for the lowest one, so I would select 2323 over 297 354, which I already know what that is. That's 0.0078 times 2,000. So 0.0078 times 2,000, which I already know what that is from up here, 15.6. 16 people from E. Okay, and so forth. Okay, I don't know that I really need to do all of this because it just asked me what kind to do, what briefly describe a sampling method. It doesn't tell me to describe how many from each one I would select, but this lets the reader know that I'm telling him exactly what I'm going to do. So there you go on that one.